Welcome to Talking Technical Illustration episode 2. This time we'll be covering S1000D illustrations. This is a recording of the webinar. Due to some technical difficulties, we could not record the webinar live, so apologies for that, but we will still be going through the same content today. Therefore, not really much point going through this part here, but we do want to inform you that we'll be participating in TDW Live this year, and if you could join our next webinar live, then you will have an opportunity to win a ticket to the event, which starts in the middle of November. More details at the end of the webinar. So if you're not aware, Larson Software, we're based in Houston, Texas, and have been for the past 30 years. We develop graphics software, mainly for aerospace and defense and manufacturing industries and oil and gas. We promote the use of CGM. We did this initially through the provision of a free CGM and TIFF viewer. We still have a CGM and TIFF viewer called VisX Reader, and that is available for subscription purchase on our website. Just go to the store and you'll be able to get a license there for 12 months. We also developed the first HTML5 CGM viewer, no plugin required, and again you can get some details on that technology on our website. So today's agenda, we'll do a quick intro to the event, then we'll be the topics we'll be covering will be S1000D illustration guidelines, file formats, S1000D and 3D data, and then we'll do a brief summary. Unfortunately we won't have questions, but obviously for obvious reasons that this is just a recording. So if you're new to the spec, then S1000D was introduced in the 1980s. The main concept was it was based on data modules, so it was the data's in modular form, and the objective of that was to give a more flexible method in managing and publishing and obviously writing technical documentation. Today S1000D is very widely used in aerospace and defense and commercial airlines. And is the really go-to specification probably globally at this point. The graphics and multimedia part of the equation are very critical and very important to the overall publishing of a manual, and that's the part we want to cover today in that particular part of the specification. Obviously no poll, unfortunately. As an introduction to the topic, we have split it down into 3 kind of subtopics, and that's guidelines, that's illustration guidelines, 2D file formats, and 3D data. So that will be the main topics for the day. Firstly, guidelines. It's very comprehensive, the specification in providing guidelines to create technical illustrations. My only comment on this would be that the illustrations would probably need to be new to kind of follow the guidelines in any detail. So if you've got legacy illustrations, it would be difficult to kind of retrospectively go back and create the illustration again or try and modify that to the spec. If it's possible, then go ahead and do it, but if it's not, obviously then that would be very time consuming. So these are kind of common sense statements, but they are kind of upfront in the spec. So illustrations must communicate in a simple and clear and economical way. They must visually enhance the technical information, in other words, the written text, and prepared in accordance with that text as well, so it actually is relevant to the procedure or to the description of a procedure. Mode of presentation, pretty much I think we're in now the IETP world, the technical manual, electronic technical manual world, where we deliver via the computer or a mobile device. Print is still kind of important, but mainly if the IETP, electronic manual, is able to print. And then really we should be looking obviously to do that in a probably a portrait mode, and possibly landscape if that's possible with a printer. So the illustration rules, the objectives really are to provide a consistent looking illustration. So isometric is the chosen perspective, and I think most illustrations are now done in this way. So there's a consistent illustration in page size, the line weights are consistent, line styles, annotations and symbols. So there's a guide for each of those particular component parts of an illustration. It also says that any extraneous data that could draw or confuse the user should be removed. Usually the illustrations are monochrome, but there is some guidelines on using colour, and those are done via a business rules decision point, which is in the spec. So this would either be defined by the customer or the project itself. So somewhere it might be something you don't do as an illustrator or a writer, but somewhere it should define if there's colour to be part of the deliverable. So you see these business rules decision points crop up in the spec, but as I said, these would be defined in the project business rules, so always worth looking through those just to make sure what the definition is or what's been chosen. They are optional, so you don't have to choose it. Line weights, again, defined for the illustration items themselves, for projection lines, hidden lines, leader lines. So you have line weights and line styles, and some kind of comments on them. Solid, dash, dot and dash dot. So all of these again are defined. And this is why I say it would probably be difficult to go back to legacy and try and adhere to all this. But new illustrations should definitely try and adhere to these guidelines, and then we have a consistency. Text style, again, it's in this case quite simple. Is that usually be Helvetica or Arial or Univers, so pretty standard typefaces. There is a business rules decision point about upper and lower case, the use of it, or sentence case. So if you, again, you might just need to make sure that you follow the guideline or the rule on that. So again, text style differs from callouts, item numbers, notes, legends. So again, take note of the point sizes that are required, and perhaps the case, uppercase or upper and lower case or sentence case. So symbols, again, very comprehensive set of symbols that have been drawn and ready to go for the illustrator. So we have here just a zoomed in view of that, so you can see the kind of forward symbols and so forth, and usually again they have a different line weights, or recommended line weights, so you should again look at these and take note and try and use where applicable. The use of colour in the specification is I think really good. They've given some very, very good examples of how to use colour and how it's denoted. So yellow, light blue and grey. So you see yellow is parts attached to the main assembly, light blue parts of on the illustration, and grey parts of a subsequent illustration.
So if there's color defined within the project business rules, then these are your guidelines to use. Plus the color palette would come into play at this point. So you should be really using light blue, light grey in this case, and light yellow for these particular style of illustration. So everything really is defined. It's back about consistency and how you use them. Now we have created an illustration template in the CGM format, which we've made available on our website. So a lot of things I've just discussed are in this CGM file, so you can either use it with our own software, which is VisXedit, or in theory you can bring it into your own illustration system via CGM. But we've actually defined all the color palette, line weights. We can look up here, we've created references to all the pens we spoke about with their correct line weights and so forth, text sizes, annotations, hotspots. So everything you really need to get going to create an illustration, even the boundary that you have to go into and the ICN number down here. So the only thing we don't really cover in this particular presentation is the ICN, the identification number. And the usual reason for that is because of the fact that it's already defined for the illustrator when they start work. So it's not something that you would define as an individual. It'd be something that we defined as a project when the data modules are decided on, their data module code, but at the same time the ICN would also be defined at that point as well. So if you want to get a copy of that, then just go to our website and you can easily download it from there. So that's the end of the first section. Obviously you can't post questions to this particular recording, but you could post questions in the YouTube channel, so please do that, or just email us directly. So that at this point we'll end the first section of the presentation. So in section 2 we're going to look at 2D file formats. Probably the best known one of these is CGM. CGM has been around for many years and has been part of the S1000D specification for many years as well. It was chosen really because it's an open format. You know, it's not proprietary. It's owned publicly, so in that case it's interoperable between different pieces of software. So this is a good thing. And it's one of the aims of S1000, was one of the aims of S1000D to base everything around open formats. So there's a whole chapter on CGM, the S1000D CGM Profile, which is now WebCGM. So let's just dive into this particular section. So if you were unaware, CGM, Computer Graphics Metafile, is a 2D graphics format, and it's still the only really deliverable file format for graphics as part of a project in S1000D. And when I say illustration, there are other formats you can deliver with the project, but these might be image files and so forth. But as far as illustrations are concerned that can contain metadata, in other words hotspots, then it would need to be a CGM file. CGM version 4 is the only one that really can contain that hotspot information, and the WebCGM profile is based on CGM version 4. It contains something called application structures, which basically gives the ability to add metadata to the file. In other words, intelligent graphics hotspots. And this can be contained embedded inside the CGM. Alternatively, there's another method using an XML companion file. So that is the other option. So you can do both ways. You can have it inside the file or external to the file. And we'll talk about that in more detail later. The profile itself is based on the ISO spec with different layers on top of that, but obviously the top layer, WebCGM 2.1, is part of the S1000D specification. So really need to, if you're using software that can create CGM, then you really need to make sure that it does adhere to the profile, because some of these projects will validate them against the spec. The other 2D format, which has become very popular, but more as a display format, is SVG, Scalable Vector Graphic. It's XML encoded. It's a WC3 format, and it's managed by the SVG working group. The big advantage and why it's really become popular is because it's native to HTML5, so there's no plugin technology required to view the graphic within the most popular browsers. So this is a big advantage. The downside is it's an enormous spec. There's a lot in there that really is not applicable to technical illustration and to the S1000D specification. So our advice at the moment is, and it's probably you'd have to do this anyway, is only use it as a display format. Because if you're delivering to a project, you would still need to deliver CGM. So best advice is keep your CGMs, keep them up to date, and then export as SVG. So you then really only need the SVG for display purposes with the IETM or ITP. So being SVG being XML encoded, can have a few disadvantages, one of them being that this file size can be larger, but it does give you that structure, and obviously it's an open format again, so that's a good thing, but we would not recommend it being used as a data exchange format, really because of the sheer unpredictability of the format from different pieces of software. To that end, we decided early on, because of this very reason, to create our own profile for SVG called Tech SVG. This would at least give us some consistency with working with SVG within our own system and exporting and saving them with that particular profile in mind, which gives us a consistent file format which we can open and export and then bring back, and it will still work. The spec, as you can see on the right, is big. So, and we only use a small portion of it for illustrations. So there's a lot in there that it's not really applicable. So we kind of just filter that out. So there are some conversion challenges that we've pretty much overcome at this point. And one of the main ones was hotspots. And now we have a consistent way of writing a hotspot within an SVG. So when you're working, say, in one of the pieces of software and you save a CGM as an SVG, the hotspot is actually embedded in a consistent way, which could be read in a viewer very easily. We also have a profile that you can go onto our website and download. So the Tech SVG profile, you can get it under the support section on our website. Hotspots is always a popular subject, and again, everything is defined within the spec, how hotspots are created and how they operate as well. So if you're creating a hotspotted illustration, it's probably worth studying this particular section. As an overview, I think I mentioned this earlier, that the hotspot really has to be defined usually within the illustration as in the CGM. But it also has to have the data in the data module itself if you're going to link the two together. Also, we find that some projects are using companion files to contain the hotspot information. This is known as an XCF, again defined in the standard, and also brand new is IMF, which is another XML format, but this one that we haven't really seen being used yet in industry. It's a lot more complex, but it has a lot more functionality. So just to go into a bit more detail, the data module is obviously XML, it's compliant with the standard. The CGM file has its hotspot information in it, and then those two can be linked. There's also the option for the XCF and the XML, which is an XML file as well, that can contain the hotspot information and other information as well. But the CGM viewer, you need to really make sure that that's actually supports the companion file. That can sometimes be an issue. The IMF, we definitely would have an issue there with viewers supporting this particular companion file. It was new in issue 4.2. As I said earlier, I haven't really seen any projects using this at this time. So I can see here in the graphic that there's the data module in the top left with the hotspot information inserted into the XML, and then we have the corresponding information on the graphic in the hotspot properties. So this now will link the two in the viewer. If you want to learn more about hotspots and interactive graphics, you should go to our blog. So if you go to cgmlarson.com and go to blog, there's a lot of different kind of information and different articles you can read on there, and one of them is about interactive graphics. In the XCF file, which is the companion file, this is actually probably the most used one of the companion files. Is the hotspot information is this time is in an external file which the data module will look up, and obviously has an association with the graphic as well. So some projects prefer this because they can they have an external file, so they're not relying on it being embedded within the CGM, and it just might be down to project rules or easier to edit. So if you're interested, the XCF structure is detailed within the S1000D spec in chapter 7.3.2, so you can look that up and find more details on it. Also within VisXedit, we can create that XCF automatically. We can export as an XCF file, and it will create the same structure as you see there on the fly. So that's a very useful function because there's a lot of information that needs to be put into that particular file. And the final one was IMF, which is the brand new one. Again, this can contain the hotspot information. But the difference is here, it can contain other metadata about the graphic. So a bit similar to the data module, it can have an ID and status about the graphic. So this means if the CSDB supports it, you could actually manage the graphic as you manage a data module with probably check-in, check-out, version control. So this could be quite powerful, especially on a big project where the illustrations need to be managed as well as the data modules. We actually wrote a blog article on the IMF, and so you can go to our website and just click on blog and you'll be able to find the article there. If you're interested in the more detail about the format in the specification, then it's in chapter 3.9.2.7, and there's quite a detailed description of the IMF file, and I think there's even an example file that you can download to see the structure of the file. Will be interesting to see if this is adopted by projects in the future. So that's the second section done. That's the 2D formats. Hopefully you've enjoyed that. So you can, if you have any questions, please post them in the comments, and we'll begin the 3D data in a few minutes' time. Thank you.
So welcome to part 3, 3D data. So this particular section, this has really been expanded on in the specification, really around interactive 3D content. So we now have quite a lot of guidance, although it's not as much guidance as saying what the functionality is, what functionality is possible when delivering 3D data. So this will obviously be a dependency of the software that you're using and to do the creation of the content. So slightly disappointed in this section that it doesn't actually define a 3D file format for delivery, unlike the 2D environment, which means it's pretty open what tools you use and what formats you deliver. So obviously we won't have the poll as this is a recording. So the general guidance is, there's a lot of similarities between the 3D guidance and the 2D. And there's a colour palette, and also you have to put in warnings and cautions and so forth, and the colours should be the same there. So this is where I was saying about authoring the data, that you have to have some kind of software that's capable of authoring in kind of annotations and warnings and cautions. Certainly something that wouldn't be standard within a CAD system. And also projects would need to define the devices and viewers and formats they're going to use in business rules. So I would say it only provides very basic guidelines, and as I said, gives you some ideas of functionality you could use. It does say that the content, 3D content, needs to be from a verified and authoritative engineering information source, but that would be definitely where it come from anyway. And as I said, it needs to contain appropriate warnings and cautions. There's a section called the technical solution, and this is where I think there's a missed opportunity. There is no recommendation for a 3D file format. All it states is that the technical solution must be defined in the project business rules. So what this really means is you could define any solution for delivering the 3D data. It could be based on proprietary, open, or whatever you want, or whatever's convenient for the project or makes sense from a cost perspective for the project. And this kind of goes against the whole reason for the specification in the first place, where we try to standardize on tools and file formats that are open. And here you have the opportunity to go proprietary. And the danger is you're going to finish up with a multitude of authoring and viewing solutions within different IETMs. And I don't think this is the great way to go. Our advice, Larson's advice, is, if you're going to go into these projects, select an open format for data exchange and display. And I think that will ultimately benefit the customer. And I don't think the cost would be any higher. To that end, we've been doing some research, investigation into different formats that are open, 3D formats that are not owned by a particular company or organization. And the one we've tended to favor at the moment is a format called X3D, which is based on XML, and it's open, and it's managed by the ISO under an ISO standard. So this would seem to make sense, both from an open standard, but also again that it's XML, which is S1000D. The spec is really mainly based on XML, so it would just seem to make a lot of sense to do the same for the 3D format. So what is X3D? Well, it's an XML file, and you have the ability to create. You'd have the ability to create a specific profile for the format, such as the text SVG or the WebCGM profile. So you could actually validate files, and the real kind of strength of the format is that you don't need a plugin to view the files in a web environment, such as an IETM web browser. So this is a big real advantage to a project. I've got some examples that could be of interest of X3D. So here we're in Chrome. We can zoom in on the model. We can orbit it. And we can even begin to pick out things on the model, say on the cam here. So you have an interaction between, you can have an interaction between the model and, say, a parts list or bill of materials, and it's all within a HTML environment, which is obviously beneficial to both the user and the project. So we really see this as a good way forward. This is another example. This time really it was designed to go on a iPad, and this is an advantage again of using a format like this, because it can go cross-platform, whereas a 3D viewer might only be limited to a desktop computer or a laptop computer. Again, it performs really well, and on the right hand side you can see that it was really designed to go on all the controls are via using the hand, using fingers and so forth, but we can explode the model using the button here, and you can see now we've got an explosion, plus we can see the annotations. Probably not the way I would do it, but it just shows you the that we could actually explode the model as well with this environment. So I think it's this has got a lot of potential, and to that end we've been doing some work to export X3D from our software, and this is one of the first examples of that. This is our kind of signature engine for Vuzix Edit 3D, and this is an X3D file, so it's XML, and we're looking at it in Chrome, and you can see the speed that it renders and so forth. So I think this is a really good solution for the industry. We're not asking S1000D to adopt it, but we're certainly pushing it forward as our solution to go forward for 3D on these particular types of project. So the only caveat we could put behind that at the moment is, although we can export X3D files, you still would need to add interactivity in a sensible and quick way, creating hotspots, connecting to parts lists, perhaps providing animations for procedural and assembly and disassembly type illustrations. So there is going to be an overhead, but I think something that's specifically designed to do that for kind of a technical manual usage is going to be beneficial, rather than trying to use a CAD system to author that kind of data. So still some work to do on that, but we certainly want to try and move in that direction. So in summary, we have a real big focus on the S1000D specification for our products, mainly obviously graphics, and we've been attending all the associated S1000D events in North America for many years, and some in Europe as well. This November we'll be participating in Technical Documentation World Live. This is a virtual event, November 17th to 19th, and you can, through that link, book tickets there for the event. If you can't attend the event virtually on the days, then it will be online for 3 months. All the presentations will be recorded and left there for people to watch post-event. We were giving away a ticket, obviously, to the event in the live session. But please join us on October 26th when we release the event details. We'll be doing another webinar. They should be coming out soon
So keep an eye on LinkedIn for that particular event, and we'll be giving away another ticket at that event as well. So thank you for tuning in today. Please send any questions in the comments. We'll be still pleased to answer them. And look out for the next episode. Goodbye. Thank you.